Okay. So it says, here's a set of problems. This is on page 115, number 8. Let's look at the first one, A. The question is the given vector in the set generated in the set, let's see, do we haven't?
How do we find this out?
Yeah, we haven't really, but okay, so, but let me tell you what generated by the set means. Question A asks the question, is 2, 3 in the set of X times 1, 4 plus Y times 1, 5, where X and Y are real numbers. So what they're really doing is they're specifying a solution set, right? They're saying, okay, if the solution set has these as the constant vectors, this is what generated by means. I won't ask you, I will be more specific. I won't use these words anywhere, generated by, but I just use this as an example. So, because I do ask the question, is this vector in this set, right? How do you answer that question? Well, what that means is, it means that you have to find X and Y such that this sum of X times this vector plus Y times this vector equals this one. Well, that means you have to find X and Y such that this is true. Okay? Well, let's multiply in X here. Well, this is X, 4X plus Y, 5Y equals 2, 3. And then let's add these two vectors together to get X plus Y, 4X plus 5Y equals 2, 3. Well, when are two vectors equal? They're equal when the components are equal. So this is true exactly when X plus Y equals 2, at the same time 4X plus 5Y equals 3. Well, that's a linear system. So this question, is this vector in this set? Is the answer to that is solve, the way to find the answer is to solve a linear system. So you have to, so now you can notice that if I write down here, let's write down the augmented matrix for this linear system. 1, 4, 1, 5, 2, 3. Now let's look up at the beginning problem. 1, 4, 1, 5, 1, 4, 1, 5. So the answer is I make the augmented matrix. See these two vectors? They appear as the columns in this matrix here. So each one of these problems, I just make the matrix of these vectors, and I've got the augmented matrix, and I solve this linear system. And if it has a solution, if I can find an X and a Y, but if there's no contradiction, then it's in the set. Okay, so let's try it. I can do this with minus 4 row 1 plus row 2. 1, 1, 2. Okay, well, minus 4 times 1, that's going to do that. Then minus 4 plus 5 is 1. And then minus 4 times 2 is minus 8. Minus 8 plus 3 is minus 5, right? So it's an echelon form. Then I have to translate it back to equations to do back substitution. And this is the X column, the Y column. So the second equation is Y equals minus 5. Therefore, the first equation is X plus minus 5 equals 2. So X equals, adding 5 to both sides, 7, right? So therefore, if I choose X equals 7 and Y equals minus 5, that should show that this combination results in 2, 3. Well, let's see if that's true. Because we can put 7 times 1, 4, plus minus 5 times 1, 5, right? And see if it equals 2, 3. Okay, well, that's going to equal 7, 4 sevens is 28, plus minus 5, minus 25, which equals, well, 7 minus 5 is 2, and 28 minus 25 is 3. So it does equal 2, 3. So 2, 3 is in the set, because if I choose x equal to 7 and y equals to minus 5, that is that vector. So you can see how to solve this problem with a linear system. So it's one place where a linear system appears that you might not otherwise expect. I think there's a problem on WigX that asks a question like this, and this is how you solve that problem. Okay,
So I think it's going into the
excuse me,
you know, it's scrolling through it, different.
here.
So no. Downward there. Okay, thank you.
Okay. So, that's sort of that's sort of the first bit of chapter 2 is what's the pattern of solutions to a linear system, and the basic special case is these singular linear systems with a coefficient matrix that's square, and so we can apply the concepts of singular and non-singular, and that answers the question. If it's singular, it has infinite number of solutions. If it's non-singular, it has one solution. So that answers the question. If we could find a way to figure out by all other easier means whether or not a matrix is singular or not, and that's one of the sort of questions going forward we have to look at. But the second half of this first chapter deals with the linear systems themselves that all have the same solutions. So the context here, let's think of this. Well, let me first